All right, so today we're going to be looking at 3.6 part 2. Last unit we looked at polynomial inequalities, and now we're going to look at rational inequalities. So remember, the first thing we always want to do is we want to rewrite the inequality if necessary, so that 0 is on one side and there's a single fraction on the other. So looking at this first example, 5 divided by x plus 4 is greater than or equal to 1. We're going to subtract the 1 from the other side and move it to the left. So we have 5 divided by x plus 4 minus 1 is greater than or equal to 0. Okay, we want to rewrite this so there's a single fraction. So our common denominator is x plus 4. So we're going to rewrite this and multiply the 1 by x plus 4 over x plus 4. Okay, and that gives us 5 minus 1 times x plus 4, all divided by x plus 4 is greater than or equal to 0. So if we simplify this, this gives us a negative 1x minus 4. Which can simplify to be negative x plus 1 over x plus 4 is greater than or equal to 0. Okay, so nothing can cancel. So now we're going to determine the values that will cause either the numerator or the denominator of the rational expression equal 0. These values determine the intervals on the number line to consider. So remember, our numerator tells us our x-intercepts, and our denominator tells us our vertical asymptote. So this is why we're going to look at both of those. So we're going to review that. So that's how I'm going to write this. So our numerator is our x-intercepts. So negative x plus 1 equals 0, which tells us that x equals 1. So we're going to add x to the other side. And then our denominator tells us our vertical asymptotes. So x plus 4 equals 0. So x equals negative 4. Okay. So I'm going to go ahead and sketch our number line over here on the right. Negative 4 and 1. Okay, so when we looked at polynomial inequalities, we kind of sketched the graph. Here, it's a little bit more difficult, but you're welcome to plug it into your graphing calculator and see what the graph is doing. I'm going to review those test points for this first example. So if we're going to use test points for each interval, I'm going to use negative 5, 0, and 2. All right. And I like to always test in our original function. You can also just plug into this bottom one. It's really kind of personal preference. So first one, we're going to test x equals negative 5. So we have 5 divided by negative 5 plus 4 is greater than or equal to 1. Well, negative 5 plus 4 is a negative 1. So 5 divided by negative 1 is greater than or equal to 1. Negative 5 is greater than or equal to 1. This is false. So I'm going to put an F above that section. Now let's test x equals 0. So we have 5 over 0 plus 4, which is greater than or equal to 1. 0 plus 4 is 4. So 5/4 is greater than or equal to 1. If you need to change that into a mixed fraction or a decimal, you can do that. And you get 5 1/4, which is greater than or equal to 1. This is true. Okay. And then let's test x equals 2. So we have 5 over 2 plus 4 is greater than or equal to 1. 2 plus 4 is 6. 5/6 is greater than or equal to 1, and that is false. So we're going to shade everything that is true. And now rational inequalities is slightly different than our polynomial because we have to be careful about our domain. Okay. So I'm going to look back over here, our vertical asymptote. Okay, x equals -4. That means in terms of our domain, x cannot equal -4. So normally, because we have greater than or equal to, we would be using brackets, which represent that equal portion. But we can't actually equal -4. So here we're going to have a parenthesis. But then at 1, we can equal 1. So we're going to have a bracket. So our answer is going to be from -4 to 1, parenthesis bracket. Okay. All right. For the second one, I want you to try this. At least try to get it set up so that it's equal to 0. And then we'll talk about the test points or using a graph to determine your intervals.